Okay, so today we're going to talk about section 4 from our book, and the majority of this section is all about using your calculator. So, although I will give you minimal notes, for the most part, you're going to need your graphing calculator because I'm going to walk you guys step by step as to how you are going to use your calculator to graph functions, to adjust your window size, and to solve for these functions. So let's just start off with basic terminology. So we're going to talk about our viewing a rectangle. And see, these terms, I just want to kind of mention them because I just want to make sure that once the book talks about them, you know exactly what they're talking about. So when we're talking about the viewing rectangle, this is literally just a viewing screen on our calculator. And I'll show you guys how to get to that. So this is our calculator. And then of a specific graph. So of course, what's going to happen is we will be able to adjust the viewing screen for each graph. And what you're going to notice is that graphs have a lot of really interesting characteristics. So if you don't have the appropriate viewing screen for them, then you're going to miss kind of like important aspects and features of the graph. Okay, so let's start off with just some basic notation. So the notation on the calculator, so the notation on your calculator is going to be as follows. You're going to have x min, which basically we're going to say let it equal to a. So that's the smallest value that you'll see on your graphing calculator. And then we have x maximum, which will be the largest, and we'll set that to b. And then we have y min, which will be the smallest y value you'll have. And then we have y max, which will be the largest. So basically, this is going to kind of create your viewing window on your graphing calculator. So technically speaking, when we're talking about these being A, B, C, and D, we're literally doing this. So we're going to have a screen where my x values are going to go from A to B, and then by my y values are going to go from C to D. So these are basically the dimensions of your screen. So these are my x values, and by y, those are my y values. So let's look at an example where we'll put our calculator to use. So this one's going to be pretty straightforward, and most of you should have some experience doing this. If not, well then don't worry about it, because I'm going to give you guys all the necessary skills needed to graph this using the calculator. So we're going to say graph f of x equals to x squared plus 3 in the following viewing angle. Okay, so for part A, our viewing rectangle is going to be -2 to 2 by -2 to 2. So basically what we're saying is we want our x values to go from -2 to 2 and our y values to go from -2 to 2. And then we're going to grab the same graph, and then we're going to graph that from -10 to 10 by -5 to 30. And then finally, we're going to go from -50 to 50 by -100 to 100. Okay, so these are the three conditions. So let's actually get our graphing calculator in. So if you turn on your graphing calculator, the first thing we want to do is, if just to graph this guy, we just press this y equals button right here. So if I press that, you'll notice that we get y1, y2, y3, and so on. And by the way, your calculators should all have slashes here. okay? If it doesn't have slashes and it has kind of like a double arrow, just talk to me and then we'll fix it, okay? Because then you won't be able to graph multiple functions on a single coordinate plane. So you definitely want all of these to be slashes. So if you have slashes, then we're good to go. So let's graph this. So first we want to put the function. So we're going to press X, and the X button is here. And then this caret here is the exponent. So it'll be x to the power of 2. And then if I press the side arrow, it'll come down, plus 3. Okay, so before I graph this, I need to adjust my viewing window. So for part A, I'm going to go from -2 to 2 by -2 to 2. So if you look exactly where I pressed y equals to graph this, next to it, it says window. And that's where we're going to adjust our viewing window. So if you press on window, notice how it says x min 0, x max 10, y min -10, y max 10. So those are my window dimensions. So what we want is we want to go from -2 to 2, and then your y minimum, you're going to press -2 to 2. And once you do that, now you're ready to graph this. And by the way, another side note, when you put x minimum as -2, make sure to use this negative and not that minus. That minus is going to give you an error, okay? So you want to go from -2 to using this. Okay, so this things you're trying to subtract something, so your calculator says it doesn't make sense. This means you're telling the calculator the number is a negative number. Okay, so coming back to this. Once we've done this, don't worry about the x scales. That just tells you how much each hash counts as. So 1 is fine. So once you get that, you press graph, and your graph will pop up shortly. Now, actually notice what happened here. The graph is actually missing. The reason why it's missing is because it's not that the graph isn't there. The graph is there. But if you look at what function we graphed, see, this is a parabola that's been shifted up 3 units. So my viewing rectangle is way off. The graph is somewhere up here. So you could see that the viewing rectangle makes a big difference, because in this case, we completely missed it. So now let's do part B. Let's go back and change the viewing window from -10 to 10 and from -5 to 30. So if I go back to window, and my x minimum will be -10, my x maximum will be 10, and then my y minimum will be -5, and y max will be 30. Okay, so if we graph this now you're going to capture the graph, which we expected this. Okay, so you could see that we see some features of this graph, which actually does a pretty good job displaying the graph. And finally, let's go and graph the viewing windows for part C, which is what, -50 to 50 and -100 to 100. And there you go. Now see, this graph makes the viewing window so large where we don't see, the parabola as well as we should. It kind of starts looking a little bit like a V or like an absolute value. So you could see that of all the viewing windows, probably part B gave us the best idea as to what this graph looks like. Okay, so let's move on to example 2. So for example 2, we're going to graph f of x equals to sine of 50x, that's a 50, using the appropriate viewing angle. So using the appropriate viewing angle. So we could actually use some of our trig skills to figure out what this is going to look like. So by the way, for a sine graph, we know that sine oscillates from -1 to 1. So we could see, and the amplitude of this guy is 1 anyway. So I might as well, we could already see just by observation that my y minimum and my y maximum, maybe I should use like -1.2. and 1.2. The reason why I'm going a little below the minimum and above the maximum is because I kind of want to try to capture the graph as a whole. But you could go from -1 to 1 also. It might slightly cut off the top and the bottom part of your graphs, okay? But, you know, as long as you go a little less than -1 and a little over 1, you're good. Okay, now, we know that sine is a periodic function. So depending on how many periods you want to capture, you could adjust your viewing window in a way where you'll be able to kind of get a better idea as to what this graph looks like. So what we know is we could use our ideas or our knowledge from math analysis to find the period for this guy, just so we can capture 1 period or 2 periods, because sometimes if you make your viewing window way too large, you might completely miss what the graph of this sine looks like. So here's what we learned. We learned that the period of any sine or cosine trig function is 2 pi over omega, where omega is basically the number in front of x. So that's omega. So what I know is that I can go from 2 pi over 50, which will be what, pi over 25, and that gives me the period. So here's what I know. Since this doesn't have any horizontal shifts, I could start my viewing rectangle in the x value starting from 0, and I could tell the calculator, hey, go up to 1 period, which is just stop at pi over 25. And that way I'll be able to capture 1 complete period of this graph, which then gives me a perfect idea as to how this graph looks, because after that it's going to start repeating itself. So coming back to this, let's graph this. Oh, and by the way, we need to make sure that we're always in radian mode, especially in this class. We're never going to work with degrees. So how do you check to see if your calculator is in radian mode? If you press on this mode right here, if you press on that mode, notice how the third row has the option radian or degrees. So right now, see, that would be on degrees. So right now, I want to make sure radian is highlighted. Once you have that, now we're ready to graph this. So the graph that the function that we're graphing will be what? It'll be sine of 50x. Okay. Now I'll go to my viewing window, and we said our x minimum was going to be 0, and our x maximum, just put pi over 25, and then your calculator will convert it to a decimal. So if I press the pi button is right there, except it's in blue, so I have to press second, the caret, which gives me pi, divided by 25. And then notice once I go down, it'll change it to decimal, which that's exactly what we wanted to do. And then my y minimum will be -1.2. My y maximum will be 1.2. And now we're ready to graph this. So if we graph it, notice we get 1 single period of this sine graph. Okay, so let's move on to the third example. So the first 2 examples we talked about practically just graphing functions. Now what we're going to do is we're going to solve functions. So there's actually 2 ways of solving this. So I'll solve them both ways. I prefer one over the other, and I'll explain to you why. So here's what we're going to do. We're going to say find the solution of cosine of x equals to x. Correct to 2 decimal places. Okay, so the first thing I want to do is this. Well, here's what we have. We have cosine of x equals to x. And see, if you go back to your analysis skills, you knew that anytime you're asked to solve for x, you try to isolate the x's to one side. And that's exactly what we're going to do. However, the good news is we don't need to use our mathematical skills, because we're going to use a calculator to do this. So we're going to do this just as before. So I'm going to subtract x from both sides, and that's going to give me cosine of x minus x equals to 0. So if you think about it, what have I just set up here? What I've set up is I want to find out when this function equals to 0. In other words, I'm trying to find its x-intercepts. So as you could see, if I could graphically find the x-intercept of this guy, then I have my solution. Okay, and that's exactly what we're going to do. So technically speaking, we're going to graph this and find its x-intercepts, which then that's our solution. Okay, so let's do that. If I come back to this, y equals, and then change this to cosine of x, make sure to put parentheses and close this up, minus x, and let's just change our viewing window from -10 or -5 to 5. Now, I'm just guessing. We might need to adjust it some more after we graph it, but let's just keep it simple from -5 to 5, and let's graph this. So how does this look? So there's the graph of cosine of x minus x. Now notice what's happening here. My solution is right there. So the question is, could I find the x-intercept? And the good news is the answer to this is yes. So how do I find the x-intercept using my graphing calculator? So the way we're going to do this is if you go to this, you see this trace button. Above it, it says calc. And this is going to do all your graphical calculations. So if I press second trace, notice how it goes to value, 0, minimum, maximum, intersect, so on. So if I want to find the x-intercept, I'm practically finding it zeros. So go down to 0, press enter, and then notice how it's going to say left bound. So all this is saying is, see, if I press the left and the right arrow, you see how that cursor is moving along the curve? It's just saying, as long as you're somewhere to the left of the x-intercept, press enter, which notice how I currently am to the left of the x-intercept. So I'm going to press enter. And then notice how it's putting kind of like an arrow here, because it's saying, the calculator is saying, so you're telling me the x-intercept is somewhere to the right of this arrow, and that's actually true. Now it's saying right bound, which means go all the way somewhere to the right of the x-intercept, and once you're to the right, you could stop and just press enter one more time. So then notice how it puts a second arrow, which this arrow is saying, now you're telling me there's an x-intercept somewhere between these two arrows. And then notice how it hasn't given me the x-intercept yet, and it says guess here, which means if you press enter one more time, then it's pretty much going to go looking for the x-intercept between these two arrows. So if I press enter one more time, it's going to do its work, and there it is. The 0 is 0.739. And since we were asked to find correct to 2 decimal places, this would just be x equals to 0.74. And there you have it. Okay. Another way you could do this is this calculator has a solve feature, which I kind of don't like, and I'll explain to you why. So think of it this way. The solve feature, here's how this works. If I get out of this mode, and if I want to solve, if you notice over here above the enter in green, it says solve. And that actually solves functions for you. So since it's in green, I need to press the alpha. So if I press alpha and I press enter, this screen is going to pop up. Oops, where is it? No, where is it? Math solver. So I'm sorry, here's what you need to do. If you go to math and you go all the way down or just press up, you'll get to solver. So if I press enter, it'll go to the solver, which then says, look, give me the equation, which basically here it is. It's cosine of x minus x. And then you press enter. Now, the reason why the solution is here is because we've already done this. Okay, so here's what you do. You just press any number. So for example, if I press 2, then you're basically telling your calculator to start from x equals to 2 and find the solution that's the closest to x equals to 2. So that's when we press the solve button. You see how there's a solve here now? So now I press alpha, solve, and then it goes solving for it. And then notice how it gives you the solution. Okay, now here's why I don't like this. The reason why I don't like this is because you may have multiple solutions, but you don't know. You'll never know because this just gives you one solution at a time. However, if you do this graphically, if your function crosses the x-axis 5 times, that means you have 5 solutions. But this just finds you the closest solution that works. An example I could give you is take into consideration x squared minus 4. See, we know that this has 2 solutions, at 2 and -2. Okay, so we don't even need a calculator, but let's pretend that we were using a calculator. If you were to graph it, you would easily see that this has 2 x-intercepts. However, if you were to use this feature, which you'd come up here and change your equation to what? X squared minus 4. And you want to find out where x squared minus 4 is equal to 0. So if I press enter and like, let's say I plug in, I don't know, x equals to 3. What it's going to do is once I get it to solve for this, it's going to find the solution closest to 3, which means it's going to find a solution at x equals 2. So let's do that. And there you have it. Notice how it gave 2 as a solution, which the calculator is not wrong. But if we don't know any better, we think that this has only one solution, and we would stop there and say that solution is 2. However, we missed a solution because we can't really see the graph. Okay, so that's why I kind of don't prefer this. I prefer to do this graphically because you could see how many solutions you have. If you have 3 x-intercepts, then you have 3 solutions. If you have 1 x-intercept, you have 1 solution. So I highly recommend that you don't use the solver feature. I recommend that you use the graphing feature, but you could do both, okay, or either. So that's basically it as far as this section goes. Like I said, it was fairly short. So you're mainly just graphing for homework, and you're adjusting your viewing rectangles. And if you have any questions during class, feel free to ask me, and I'll be more than happy to help you out.